Problem number 2 of the 2006 MIT Integration Bee Quarterfinals, quarterfinal number 1. It's a fairly challenging problem, but easy all the same. The definite integral from x equals to 0 to x equals to 4 of 3 to the power square root of 2x plus 1. So let's quickly see how we may be able to solve this problem. Thing as it is, my principle is we would want to substitute for the complicated part, and the complicated part here is 3 to the power square root of 2x plus 1, the entire integrand. So I would say let u be equal to 3 to the power square root of 2x plus 1. That means that if I use the natural logarithm of u on both left and right hand side, we have natural logarithm of u be equal to log 3 to the power square root of 2x plus 1, and using the rules of logarithm, this square root of 2x plus 1 can now go on to the left hand side of the function log, and so we have log u being equal to the square root of 2x plus 1 times log 3. And so the derivative of log u is 1 over u du dx now equals to the derivative of square root of 2x plus 1 is 2 over 2 times the square root of 2x plus 1 times log 3. And from this expression here, square root of 2x plus 1 is the same as log u over 3. So we can substitute for that, and we now have 1 over u du dx being equal to 1 over log u over log 3, natural log 3 times log 3. So rearranging things, we have log u over u du dx being equal to log 3 squared. And that means that now we can have 1 over log 3 all squared times log u over u du being something we could use to substitute of dx. And then the limits, as when x is 0, that means it's 3 times 2 times 0 plus 1, that is 3 to the power 1, so that is 3. And when x is 4, that is 3 to the power square root of 2 times 4, which is 8 plus 1 is 9, square root of 9 is 3, so 3 to the power 3. And so now our equation in the x domain becomes the integral from u equals to 3 to u equals to 3 to the power 3 times of u times 1 over log 3 squared times log u over u in the u domain. And the u's here cancel, so we have this constant 1 over log 3 squared that can be pulled out, and we're left with log u as the integrand. And now we can now express log u, the integrand, as a product of log u times the derivative of u, since 1 is the derivative of u with respect to u. And so we can now go ahead and use integration by parts, where we have the product of u and v being equal to u times log u minus 1 over log 3 squared times the integral of u times the derivative of log u, which is 1 over u. And so 1 over u times u cancel in the second integrand, and that means that we just have the integral, or the integrand, the integral of 1. So applying the limits, 3 lower limit, 3 to the power 3 upper limit to the first integration result will be what we'll undertake the next steps. So as you can see here, we have the integral of 1 in the second integration that we've created, which means that we can now have u as our remaining variable. And when we substitute the lower and upper limits, on the lower limit, the upper limit, we have 3 to the power 3 log 3 to the power 3 minus 3 log 3, and that's for the first result, minus 1 over log 3 to the power 2 or log 3 squared of, for the second result here, since we only have u, it becomes 3 to the power 3 minus 3. 3 to the power 3 is 27. 27 minus 3 is 24. And here we can pull out the 3 here. So instead of 3 to the power 3, we have 3 to the power 4 log 3 minus 3 log 3. 3 to the power 4 is obviously 81. 81 minus 3, that becomes 78. So we have 78 log 3 over log 3 squared minus 24 over log 3 squared. So our answer quickly just becomes 78 times log 3 minus 24 over log 3 squared. Therefore, the way we could express it in the final succinct way is that the integral from x equals to 0 to x equals to 4 of 3 to the power square root of 2x plus 1 equals to 78 log 3, that's natural log of 3 minus 24, all divided by the square of log 3. And that is our final answer.